Good morning friends. Last we discussed for magnification for the simple microscope, that means the optical instrument. We obtained the equation of magnification for simple microscope, in which case if the image of an object is formed at near point distance d, near point distance d, that means that is the distance we can obtain or we can visible the object or the image without any stress and also with comfort. So that is known as the near point distance, and for human eye the normal point distance d is equal to 25 centimeter approximate. If in example there is not given, suppose we want to acquire for the numerical value, so take the d, capital D is equal to 25 centimeter. That is the near point distance. Okay. Now today we are going to discuss or obtain the equation of magnification for the image formed at infinite distance for a simple microscope. In last lecture we also discussed about that if the simple microscope is a magnifier lens or converging lens, right? That means the convex lens. Now there is the principal focus, and the object is placed at principal focus, so its image is formed at infinite distance. Suppose the object is placed between optical center and principal focus, so its image is formed on the same side, and also this image is react and magnified. React and magnified. That means this way the image is formed. So for this case, in last lecture we derived the equation of magnification, and this equation M is equal to 1 plus D upon M. 1 plus D upon M. Now today we are going to discuss about that for this simple microscope. Suppose the object is placed at principal focus, so its image is formed at infinite distance. So how we obtain the equation of magnification? For that purpose, here we consider, suppose the object of height h is easily or clearly visible if we place this object at near point distance d from our eye. So in short, we place the object at near point distance, we can easily visible without any stress and with comfort at distance d. Now the height of an object is x. This subtend an angle theta 0 with the eye, where the eye. The angle subtended by the object is theta 0. Now from the figure, what is the tan theta 0? Tan theta 0 is equal to opposite to the adjacent, therefore h upon d. But here the angle subtended is very small. Therefore for small angle, tan theta 0 is approximate theta 0. Therefore we can add theta 0 is equal to h upon d. That is the equation 1. There is in case without any lens we can see the object of height h clearly and with comfort. Now suppose the object is placed at principal focus of a convex lens, like this way. There is the convex lens, there is the principal focus, object is placed here. So to obtain the image of this object, we have to consider the two rays. One is parallel to the principal axis, second is passes through the optical center of the lens. Okay. So this ray after the reflection must be passed to the principal focus. So both rays becomes the parallel. It means the image of this object is formed at infinite distance, and we extend these two rays in that direction. This way. The angle subtended by the image is, there is the theta I. Theta I. So that is the angle subtended by the image which is formed at infinite distance. For that purpose, if an object is placed at u is equal to f distance from a lens, the angle subtended by the image at I is theta. Therefore, tan theta I is equal to tan theta I is equal to h upon fo for the object, for the h upon f. That is, and if theta I is very small, therefore we can take tan theta I approximate theta I. Therefore, theta I is equal to h upon f. Equation number. Thus, in two different methods, first without lens and second for lens, replace the object at principal focus and its image is formed at infinite distance, we obtain the equation of its angle. Therefore, the angular magnification for simple microscope is the ratio of theta I to the theta 0, that means the angle subtended by the object. Now listen here. Thus, the angular magnification for simple microscope is m is equal to theta I upon theta 0. We substitute the value of equation 1 and 2, therefore h upon t upon h upon f. H upon, therefore h is cancelled, therefore 1 upon d into f upon d. Thus we obtain the m is equal to d by f. D by f. So that is the magnification for the simple microscope in case of if the image is formed at distance infinite. Clear this? Okay. Thus the magnification for image formed at infinite is less by 1, then the magnification for image format at near point distance. Here is, so there is the m is equal to d by f, and earlier we obtained the 1 plus d by f. Theta I value is h upon f. Here the h upon d is equal to d by. So that is the equation of the magnification for the simple microscope if the image is formed at infinite distance. Clear this? Here we are using this concept in next microscope, that is the compound microscope. Here the simple microscope, in this simple microscope we are using only the single convex lens. So it has the certain limitation for maximum magnification. We discuss in next point in compound microscope. Okay, now that we discuss about the simple microscope, and for simple microscope the magnification M is equal to D upon F. D is the near point distance, F is the focal length of the convex lens. Because in simple microscope the single convex lens is used. From this equation one can say that to improve the magnification of a simple microscope, the F value of the F must be small. That means we have to use the convex lens or the converging lens with smaller focal length. Here, what's happened? If the focal length of a lens is decreases, what's happened? This lens becomes the thick, and due to that, the distortion is take place in the image. Therefore, up to a certain value of the focal length, we can't minimize we can't take the smaller value of the focal length. So there is the limitation for simple microscope. And due to that reason, to obtain the maximum magnification, the some limitation take place in simple microscope. So how we obtain the more magnification of this small or the minute object? For that purpose, here the compound microscope is used. The principle of the compound microscope is that whatever the image formed by the simple convex lens, so that is the image. So there is the simple microscope. Now, this image is act as a virtual object for other lens, and its enlarged image is formed at infinite distance. So thus there is the concept of the simple microscope. The compound microscope. So in short, in compound microscope, the one uses the two lens. And the compounding the effect of each other lenses is known as the compound microscope. For that purpose, the idea like that way, the simple microscope has the limited maximum magnification for realistic focal length. To obtain the more magnification, the one uses the two lenses. And the compound effect of the lenses over each other is known as the compound microscope. So there is the concept of the compound microscope. In simple microscope, the limited maximum magnification for realistic focal length. To obtain more magnification, one uses two lenses. The compounding effect of each other now that means the device with the two lenses is known as compound microscope. Now, what is the schematic diagram of the compound microscope? Schematic diagram. We do the diagram here. So that is the common axis of these two lenses. Here, the one lens that is small in size, and here the object is at distance u from the this lens. To obtain the image of this, the two rays are equal. One is passes to the optical center and second incident on the lens. This is parallel to the principal axis. After the reflection, this ray must pass through the principal focus. So its image is formed here. So here the object is A, B, the height is H. Height is H. Distance is U. Distance is U. Now there is our B1. There is our B1 point. Actually this distance is focal length. Focal length. There is our objective lens O. Objective lens. So this part is same as the image. Okay. Now this image format having the height is H dash and that is the radius B dash. Now we use another lens. Here is the eyepiece. So these two rays are these rays are entered to the eye of a person. Eye of a person. That is the answer. So the final image A double dash B double dash is formed at near point distance B. Near point distance B. So this is the eyepiece B. Now this distance is the focal length of eyepiece, and the remaining this distance is the tube length. That means the distance between the BDS and so there is the schematic diagram of the compound microscope. Now friends, it is not very easy. So you have to do 2 or 3 times. So every time this is a mid. Otherwise what's happened? Here the eyepiece is small. This is below the eyepiece or above the eyepiece. So due to that result, in front of you, I drew this diagram. Okay. So again, what is the schematic diagram of a compound microscope? Here, an object of height h is placed at due distance from the one convex lens that is known as objective. Okay. To obtain the image, the two rays are required. One is passing through the optical center, and second is parallel to the principal axis. After the reflection, it must pass through the principal focus of a lens. Okay. Both have meeting at point A dash. Therefore, A dash is the image of A. Therefore, A dash, B dash is the image of object, and height is H dash. Now, for this image is act the virtual object for second convex lens. And second convex lens, that is our eyepiece, forms the image at infinite distance or the near point distance, and this image is that is the inverted and magnified, or the virtual and magnified. Due to the first lens, which type of the image is obtained? The image is inverted and also the magnified. Real, inverted and magnified image is obtained, while in second, the virtual and magnified image is obtained. So this is the schematic diagram of our compound microscope. How we describe it? The lens near the object is known as the objective, and the lens near the eyepiece or the eye is known as the eyepiece. Now, as shown in figure, the lens near the object is objective and near the eye is eyepiece. The diameter and focal length, the diameter and focal length of eyepiece is more than objective. That means the focal length and diameter of eyepiece is much more than the objective. Now, objective forms. The objective forms which type of the image? Inverted, real and magnified. Inverted, real and magnified image. While eyepiece forms here visual and magnified image. Magnified image. The image formed by the objective is act as a virtual object for the eyepiece. The image formed by objective is act as a virtual object and eyepiece works as a magnifier or simple microscope. And its image is formed at near point distance. Near point. Actually, there is the infinite. There is a infinite. So that's the schematic diagram and construction of the compound microscope. Again, there are two convex lenses. The convex lens near the object is known as objective, near the eye is known as the eyepiece. The diameter and focal length of eyepiece is more than the diameter and focal length of an objective. Now, objective forms which image is inverted, real and magnified, that means more than the real object. Okay. This image acts as a virtual object for eyepiece. Eyepiece here works as a simple microscope or the magnifier, and the final magnified image is obtained at infinite distance or the near point distance by the eyepiece. So this is the function of the working of a compound microscope. Now we are going to obtain the equation of magnification for the compound microscope. Clear? Okay, now we are going to obtain the equation of magnification for compound microscope. Here, how to obtain the magnification? Because here the final magnification is taking place due to the combined effect of the two lens. One is objective, second is the eyepiece. Therefore, separately we have to obtain the magnification of objective lens and magnification of eyepiece. Already we discussed about the magnification by eyepiece. Here, our eyepiece is act as a simple microscope. For simple microscope, already we obtained the equation of magnification M is equal to 1 plus B upon F. In which case, if the image is formed by the lens at near point distance D, and if the image is formed at infinite distance, so magnification is D upon F. So here our eyepiece is act as a simple microscope, and here the objective is act as our main lens in compound microscope. So our aim is first to obtain the magnification due to objective. Okay. Now for that purpose, the linear magnification. The linear magnification due to objectives is, there is the MO, most M for objective is equal to HDS upon H. Already we have the definition of the height of an image to the height of an object, that is known as the linear magnification. Then the equation number 1 here, HDS is equal to dimension of a first image, because this first image is ADS BDS formed by the objective lens, and S is equal to dimension of an object. Okay, object. That's it. Now in figure, consider triangle. Now for that purpose, keep in mind that here, so AB, so this distance is also AB. Here we take, there is the O here dash, for the suppose O1. O. So the name of this point is O1. Therefore O1B1. Now listen. So what are the angles subtended? The same angles subtended here. Suppose there is the beta. There is the beta. So we consider this triangle O1B1. Consider triangle O1B1. Therefore tan beta. Tan beta is equal to what? O1 upon OB1. O1 upon OB1. O1 is same as the AB. AB is equal to H. Upon OB1. OB1 is the focal length of the objective, that means the F. Therefore, H is equal to F tan beta. That is the equation number 2. And for triangle, we consider another triangle, this triangle, that is the ADS, BDS and B1. ADS, BDS, B1. ADS, BDS. Again the angle is beta, therefore tan beta is equal to tan beta ADS, BDS upon B1, BDS. B1, BDS. ADS, BDS upon B1, ADS, BDS, SDS upon, there is B1B. B1B is the tube length of a telescope. That is there. Here B1, BS is equal to L is equal to tube length. Is equal to tube. Therefore, HDS is equal to L tan beta. Equation number, substitute 2 and 3 in 1. Substitute equation 2 and 3 in 1. So we obtain the L0 is equal to, now H dash is equal to L tan beta divided by, now H is equal to equation 2 F0 tan beta cancel, therefore L upon F0, there is the equation number 4. So that is the magnification for our objective lens. Now for eyepiece. For that purpose we are using, directly consider this equation of magnification for eyepiece through simple microscope. For eyepiece, if an image is formed at near point distance, near point magnification is ME is equal to 1 plus D upon F. F is the focal length of eyepiece, right? And if n is for man at infinity, the ME is equal to D upon F. Therefore, total magnification of compound microscope is M is equal to MO into M, because that is the combination of two lenses. Already we obtained the equivalent magnification for combination of two lenses. Okay, so magnification is equal to the product of magnification of individual lenses. MO into M. MO is equal to M upon MO. And here there is the D upon F. There is the magnification of compound microscope. So from this equation, there is equation number 5. To obtain the large magnification of a small object, the objective and eyepiece should have the small focal length. Or what are the objective and eyepiece I use? Should have the small focal length, because the F0 and FE are small, so magnification is small. To obtain more magnification, of a small object, objective and eyepiece should have small focal length, So that is the magnification of the compound microscope. So this way you can obtain here the importance of the figure. Right? How we obtain the first magnification for the objective? By considering these two triangles, O1 B1 and radius BDS. And then we obtain the M0 and ME. We directly set from the simple microscope, and to obtain the resultant magnification or the total magnification of compound microscope, we multiply the magnification of objective and eyepiece. Thus, the resultant magnification M is equal to L upon F0 into D upon F.